Hey, we should review the physics unit on momentum and collisions for Mrs. Hubert's class. We will be having a test soon.
That's a very good idea. I wish I had learned about momentum and collisions before I made this career choice. The life of a crash test dummy is pretty stressful. A better understanding of physics may have helped me through this week's crash test with a little less trauma to my body.
That is so true. Physics is not only good general exercise for your brain, it is also practical knowledge to have in many everyday situations.
Yeah, we should make sure we are really paying attention and working hard in Mrs. Hubert's physics class every day. I'm ready to start reviewing.
First, let's talk about important vocabulary. How about if I give you a term, and you tell me what you think it means?
Okay. I logged a lot of brain damage this week, but I'll do the best I can.
Here's the first one. What is momentum?
I think momentum is like the amount of motion associated with an object. Momentum is calculated by multiplying mass times velocity, so it is weird units of kilograms times meters per second.
That is correct. Plus, it is important to note that momentum is always conserved in any interaction between isolated objects.
Yeah, I know what conservation of momentum means. The total amount of momentum in a closed system always stays the same. When you think about momentum being conserved, it is important to realize that momentum is a vector. That means two objects could be moving toward each other, and although each one has a non-zero velocity and non-zero kinetic energy, the total momentum of the system could be zero if the two objects are originally in equal and opposite momenta. If the two objects with equal and opposite momenta collide head-on and stuck together, the velocity and kinetic energy would be zero after the collision.
Well, that is all true, but I wish you would not interrupt me. That is just rude.
I am sorry. I usually have good manners. I guess I bounced my head off the steering wheel one too many times this week.
Apology accepted. Here is another vocabulary term. What is an elastic collision?
Well, elastic sounds like something stretching and then snapping or bouncing back to its original shape or position. So I would guess that elastic collisions occur when things bounce off each other.
That is true. Objects will bounce off each other when they collide elastically, but there is more to it than that. Momentum is always conserved, but in an elastic collision the kinetic energy in the system is also conserved. This means that no energy is lost to friction, heat, sound, or deforming objects in an elastic collision.
Gee, that doesn't sound like it happens very often in the real world. I mean, pretty much anything that collides with something else makes some sound and heats up a little from the collision, right?
Yes, in reality, perfectly elastic collisions are very rare, but once in a while, most of the kinetic energy is conserved. Physicists often refer to collisions between billiard balls and other non-deforming colliding objects that bounce off each other as nearly elastic, or just as elastic, even though we all know they are not perfectly elastic.
So it must mean that an inelastic collision is one in which most of the kinetic energy is not conserved, but instead kinetic energy gets converted into sound or heat or other energy forms when an inelastic collision occurs.
Yes, and a perfectly inelastic collision occurs when two objects collide and totally stick together. In a perfectly inelastic collision, kinetic energy is definitely not conserved because the two colliding objects stick together to become one new object.
Does the kinetic energy have to be zero after an inelastic collision?
No. The total kinetic energy in the system will be reduced after an inelastic collision, but the stuck-together masses may still be moving.
I guess it makes sense. Like if a truck traveling down the freeway hits a deer and the deer sticks in the grill of the truck would probably still be moving after striking the deer. The truck with the deer stuck on it would just slow down some. So in this type of inelastic collision, there would still be kinetic energy after the collision. The kinetic energy would just be reduced.
How about one more important vocabulary term? What is impulse?
I know this one too. Impulse is just a fancy word for change in momentum. Since impulse is a change in momentum, it has the same units as momentum, kilograms times meters per second. The interesting thing about impulse is that you can calculate it in different ways. You can subtract initial momentum from a final momentum to get impulse or change in momentum. Or, you could multiply the force that is creating the momentum change times the length of time in which the force is acting to make the momentum change. Since force is measured in newtons, which is kilograms times meters per second squared, when you multiply newtons times seconds, You end up with the units of momentum. Pretty cool, huh?
Yes, that is cool. You know, you are pretty smart for someone who experiences head-crushing forces for a living.
Thanks. I guess I've learned a lot in Mrs. Hoopert's physics class.
Me too. The impulse equation, impulse equals force times time, has a lot to do with vehicle safety. Do you remember why?
Yes. Think about a vehicle of a certain mass traveling at a certain speed that collides with something that doesn't move much, like a cliff face or a bridge support. A certain impulse, or change in momentum, will have to occur as the moving car comes to a stop during the collision. There are two extreme ways for this impulse to occur. Either you could have a smaller force acting over a longer time, or you could have a greater force acting over a shorter time. If you want to survive the collision, a smaller force acting over a greater length of time is preferred.
But sometimes people complain about modern vehicles and how a little fender bender can do thousands of dollars in damage to a car nowadays. Some people even think that the larger, more rigid, older vehicles were safer since they could smash into things and sustain very little structural damage on the vehicle. But it just isn't true that the older cars were safer. The impulse equation tells us the only way to reduce the force on the passengers involved in a collision is to lengthen the crash time. The safety features in modern vehicles are designed to make the crash time increase so the force can decrease.
Right. Crushable bumpers, crumple zones, collapsible steering wheels, soft rounded dashboards and seats, and airbags are all designed to lengthen the crash time while they deform. Seat belts keep passengers attached to the passenger compartment so that they decelerate more slowly and experience lower crash forces.
Also, the passenger compartment in a well-constructed vehicle is designed to not crush or collapse. The entire outside of a vehicle can crash, collapse, and tear off, and that will all lengthen the crash time and reduce crash forces on passengers. But the passenger compartment has to stay rigid so the passengers don't get crushed inside the vehicle. So, modern vehicles may have thousands of dollars in damages when involved in a collision, but people are much more likely to survive the accidents in newer, safer vehicles.
Hey, how about if I quiz you about collisions and energy transformations?
Okay. Try to stump me.
Oh, really? Usually crash test dummies don't want to be stumped. My leg was torn off at the knee just last week in a violent crash.
You're right. Poor word choice. My bad.
All right. Well, I'm sure you know what kind of energy a car is when it is traveling down the crash path.
Yes, moving vehicles have kinetic energy. Kinetic energy is the energy of motion.
That was weird.
It is calculated by taking 1/2 the mass of the moving object times the square of its velocity.
The squaring of the velocity in the kinetic energy equation is very important. Most vehicle crash tests are performed at only 30 miles per hour. Let's say a crash test car is speeding down the freeway at 90 miles per hour. How much more kinetic energy would the car have at freeway velocity compared to the crash test velocity?
Let's see. 90 miles per hour is 3 times greater than 30 miles per hour. So velocity is 3 times greater on the freeway, which means the kinetic energy is 3 squared times greater. 3 times 3 is 9. So there would be 9 times more kinetic energy in a vehicle traveling at 90 miles per hour compared to a vehicle traveling 30 miles per hour.
Wow, that's a lot more energy. So what does that tell us about velocity and vehicle safety?
Well, really, if you are going super fast, there are no safety features capable of dissipating the huge amount of kinetic energy associated with high speeds. At slower speeds, good safety features will lengthen the crash time and reduce the forces experienced by passengers. But at high speeds, there is simply too much kinetic energy for safety features to dissipate, and passengers are much more likely to be injured or killed.
You keep saying that the safety features dissipate the kinetic energy, but energy is always supposed to be conserved, right? Where does the kinetic energy go when it dissipates?
It is converted into other forms of energy. Remember the work kinetic energy theorem? The net work done on an object is equal to the change in kinetic energy of the object. That means that the loss in kinetic energy during a collision is equal to the work done by the brakes plus the work done crushing the bumper, crumple zones, and other parts of the vehicle. The kinetic energy gets converted to other forms like heat or sound energy. Oh no, That sounds like kinetic energy being converted right now.
Yeah, and it sounds like our coworker just experienced an extremely short collision time.
Oh well. Better him than us, right?
I guess.